So what's up with internal resistance? Inside the battery, we have the chemicals that are producing the voltage. Those chemicals lie between metal plates represented by these vertical lines, and they produce what's called the electromotive force. It's abbreviated EMF. It's not really a force, it's a voltage, but it's a historical term that we still use. Now that voltage is going to be countered by a resistance of the chemicals themselves, represented here by a resistor, which we'll call the internal resistance. So the battery is now going to be represented by everything inside that blue dotted line. These dots will represent the terminals of the battery. And the voltmeter reads 1.6 volts. That is the voltage produced by the chemicals in the battery. There's no voltage loss through the resistor because there's no current flowing through there. If you have no current flowing through the internal resistor, you'll have no voltage drop across that resistor. Now what happens when we hook this up to our light bulb? Now we will have current flowing through the internal resistor, and the voltage at the battery terminals drops to 1.52 volts. We're saying that the chemicals are giving us a gain of 1.6 volts. And then as the current flows through that resistor, we're losing 0.08 volts. So we can say that the positive end of the battery is at 1.52 volts, assuming at the negative end we're at 0 volts. Now we'll use Ohm's law to determine the current going through the bulb. In a previous experiment, we found that the resistance of that bulb while on is 8.9 ohms. The voltage drop across the bulb was 1.52 volts as measured by the meter. And the current is found to be 0.171 amps. Well, that's the same current that's going through the internal resistor. Well, we have 0.08 volt drop across that internal resistance and a current of 0.171 amps flowing through it, so we can calculate the internal resistance, which gives us an internal resistance of 0.468 ohms. Now, you don't notice that internal resistance loss if there's no current flowing through. The chemicals push forward, but if there's no current going through here, you're not going to have a loss because there's no current times 0 times a resistor would give you 0 drop in voltage across that resistance. So you only notice the drop in voltage when there's current flowing through a circuit going through the battery. Let's try another example. Here we have a battery. Everything inside the dotted line is representing the battery. And we have a resistor that's separate from that internal resistance. And sometimes we label that RL, and the L stands for load, as a load resistor of 20 ohms. With the switch open, I hook up the voltmeter and it reads 3 volts. So what's the value of the EMF, the voltage produced by the chemicals in the battery? It's going to be 3 volts because there can be no loss through that resistor internal because the switch is open and there's no current flowing through. Now the switch is closed and the voltmeter drops to 2.7 volts. That is now the terminal voltage of the battery, which is connected to the resistor, the 20 ohm resistor, which we will use to calculate the current flowing through the circuit. And that's how much current is flowing through this circuit. It's going through the load resistor, and it's also going through the internal resistor, which causes a drop of 0.3 volts through the internal resistor. Using Ohm's law, we'll be able to calculate the value of the internal resistance. And this gives us an internal resistance of 2.22 ohms.